All right, this is Math 200. We're looking at Chapter 8. This is 8.3. We're solving second-degree equations, quadratic equations, and we're using either factoring or quadratic formula. So let's take a look. Let's move this 12x over. And we have this 4x squared minus 12x plus 4 is equal to 0. So we can factor 4 out of everything. So let's pull out the greatest common factor of 4. We divide everything by 4. And so we end up with x squared minus 3x plus 1. So we're looking to factor it if we can. So a list of suspects for 1, that multiplies to be a negative. Well, there's only one suspect, and that would be -1, -1. And that would add up to -2, which is not 3. So this is not factorable. It's prime. But since it's a second degree equation, we know the fundamental theorem says there's 2 solutions. So there are 2 solutions for this. They're just not pretty solutions. If it's factorable, that means it's either a whole number answer or a rational answer, one that could be written as a fraction. Since this is not factorable, there are answers, it's just they're irrational. They're non-terminating, non-repeating decimals. So we're going to use quadratic formula to find this answer. So remember, quad form is, what is it, the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So we don't need to put in 4, -12, and 4. We can actually put in the 1, -3, and 1. This 4 multiplier will affect the graph, but it won't affect the zeros. The graph will be stretched by a vertical factor of 4, but the zeros will be in the same spot. So we can just use the smaller numbers. So let's put those in. Everywhere where we see a b, we're going to put a -3. Everywhere where we see on A, we're going to put a 1, and C gets a 1 also. So we sub in +1, -3, and 1 into this equation for A, B, and C. And now we work it out. 3 plus or minus the square root of 9 minus 4 all over 2. That is 3 plus or minus the square root of 5 all over 2. And I think that's all we have to do. Yep. So just there are 2 solutions there. That is x is equal to 3 plus the square root of 5 over 2, and x equals 3 minus the square root of 5 over 2. You can just leave it in the shorthand. If you want to write out 2 answers, you can totally write out 2 answers. But you can leave it shorthand like this. It's irrational, meaning that this 5 never stops. It's non-terminating, non-repeating. We're going to add 3 to it and then divide it by 2, but it's still going to be non-repeating and forever continuing. So we can just leave it like that. If it comes down to a problem, like a practical problem that we're trying to figure out, then we would use decimal approximations. All right? So let's do another one. So the next one is 5/8 m squared plus m minus 1/2 equals 0. So again, we don't want to work with fractions, and we don't have to. It's an equation. We're looking for zeros. So we can multiply everything by 8 because that's the LCD. The LCD between 8 and 1 and 2 is 8. And so if we multiply everything by 8, look at what happens. These 8's cancel. We have 5m squared. That's plus 8m. And 2 goes into 8 4 times. So minus 4 equals 0. So again, if you want to, you can use quadratic formula A, B, and C. I think I'm going to try to factor. Let's do the AC method. of factoring. Remember how that works. We take 5 times negative 4, that's negative 20. Things that multiply to be negative 20, negative 1 and 20, negative 20 and 1, negative 2 and 10, negative 10 and 2, negative 5 and 4, negative 4 and 5. Everything that multiplies to be negative 20, this one adds up to 8. So this is factorable. Negative 2m plus 10m. We'll leave the minus 4 where it is. 5m squared where it is. So on the first two, I can factor out an m. And we get 5m minus 2. On the second two, I can factor out a 2. And we get 5m minus 2 again. And so now we can factor out a 5m minus 2, an actual binomial. Pull that out. And then we're going to be left with m plus 2. So here are my two solutions. I got 5m minus 2 is equal to 0, and I got m plus 2 is equal to 0. This one's easy peasy, minus 2. And m is equal to negative 2. This one is a little tougher. We add 2 and then divide by 5. So m is equal to 2/5. All right, so two solutions. Let's get the next page, page 9. 11. Wow, these take up a lot of room. That's the problem, huh? All right, so there we are. So on to the next one here. We've got x minus the square root of 2x is equal to 4. So we can subtract x. So we have negative square root of 2x equals negative x plus 4. Divide by negative 1, everything by negative 1. So we isolate the square root essentially. And now we're going to square both sides. And the reason we're squaring both sides is to eliminate this square root. So now the square root squared is just 2x. This is x minus 4 times x minus 4. Remember how that works. We get x squared minus 4x plus 16. Let's row over the 2x over. And we're going to write this on the left side. So I have x squared minus 8 minus 2 is minus 10x plus 16 equal to 0. And so look, here's the step I skipped. 0 is equal to x squared, and put all that together, minus 10x plus 16. So I just wrote this on the left side, that on the right side. All right, so now we're looking for multiplies to be 16, but adds up to be negative 10. List of suspects for 16, but adds to a negative. That would be negative, negative. -8, -4. This one did it. X minus 2, x minus 8 equals 0. So I get two answers, but now you have to be careful. Whenever there's a square both sides step, you've got to remember to check both answers, because one of these might be extraneous, meaning if I put it back in, it doesn't work. So let's see, I put 2 in, and I get 2 minus the square root of 4. Does that equal 4? And the answer is no, it doesn't. It equals 0. So this one failed. Let's try 8. 8 minus the square root of 16, does that equal 4? Yes, 8 minus 4 is 4. That one works. That one fails. It usually has to do with the sign. And so be sure to check whenever there's a step where you square both sides. Be sure to check your answers, all right? So only one answer that works for that one, 8. Let's do the next one. So the next one, solve it. If we've got this. So we're looking at LCD again. LCD here is